Now we will discuss the transformation W is equal to 1 by Z. So in the case of discussing a transformation, you should first know in the Z plane, okay, you will be calling it as the domain plane, and its image is represented in W plane. You require actually 4 coordinates. Okay, you have a two-dimensional transformation. Okay, this will be your transformation f of z. W is equal to f of z. Okay, so now what we have to do is we have to give the properties of the transformation W is equal to 1 by z. For that, what we do is we take a convenient function in the domain and find its corresponding image. Before moving into the problem, I'll first separate the real and imaginary parts of the function z is equal to 1 by w, because you know that this z plane contains x and y. So if I want to find its image, I have to replace x and y in terms of u and v. So this will be 1 by u plus iv. Now what I do is I multiply by the conjugate of the value u plus iv in the right hand side, namely u minus iv, and I get u minus iv by u squared plus v squared. From that I get x is equal to u by u squared plus v squared, and y is equal to minus v by u squared plus v squared. Now I have separated it into real and imaginary parts. I have found x in terms of u and v, and I have also calculated y in terms of u and v. So now what I do is I consider the curve a into x squared plus y squared plus 2bx plus 2cy plus d is equal to 0. Okay. Now what is the speciality of this? When I take a not equal to 0, the above equation represents a circle. Okay, it represents a circle. You can also find the radius as minus b by a and minus c by a, and you can also find the radius. I am not going into this. And when I take a is equal to 0, x squared plus y squared gets vanished, giving you a linear equation in x and y that will represent a straight line. So what I do is I represent a circle and a straight line in one equation. Depending upon the particular value of the constant, it becomes a circle or a straight line. Now what I am going to do is I am going to find the image of this particular function. So now what I do is I replace x with u by u squared by x squared is being replaced with u squared plus v squared the whole squared plus v squared by u squared plus v squared. Okay, this will be a into x squared plus y squared plus 2bu by u squared plus v squared minus 2cv by u squared plus v squared plus d is equal to 0. Okay, when I simplify this, I will have a by u squared plus v squared. Okay, is that right? Plus 2bu by u squared plus v squared plus, sorry, not plus, minus 2cv by u squared plus v squared plus d is equal to 0. And when I multiply with u squared plus v squared throughout, I will have a plus 2bu minus 2cv plus d into u squared plus v squared is equal to 0. So this will be the image. Okay, you can see that this will be the image of the curve a into x squared plus y squared plus 2bx plus 2cy plus d is equal to 0. So now what I am going to do is, okay, I am going to discuss certain cases. Before that, let me write the curve as a into x squared plus y squared plus 2bx plus 2cy plus d is equal to 0. Okay. Now what will be its image? Its image will be a plus 2bu minus 2cv plus d into u squared plus v squared is equal to 0. Okay. I'll first divide this into 3 cases. This will be more appropriate. Okay. Now what I do is, I'll take the z plane here. Okay. And I will write down the corresponding image here. So the first case will be a not equal to 0 and d is not equal to 0. So now what I do is, I take a and d not equal to 0. When I take a and d not equal to 0, I will have circle in the z plane. Okay. And because a and d are not equal to 0, that will get mapped to circle in w plane. This one is quite obvious. Okay. So the first case here is that when I assume a is not equal to 0 and d is not equal to 0, I will have circle in the z plane that gets mapped to circle in the w plane. And similarly, I take the other case, a equal to 0 and d is also 0. When I take a is equal to 0, x squared plus y squared gets vanished, d becomes 0. So I'll have 2bx plus 2cy, which is a straight line through origin. In w plane, you will have straight line through origin. And when I take a and d is equal to 0, again I will have straight line through origin in w plane. Okay. So now what happens here? I will have straight line through origin. This will be case 2. Okay. Now the third case will be a not equal to 0 and d is equal to 0. Okay. When I take it in the z plane, a is not equal to 0. So I will have x squared plus y squared. But d is equal to 0. So I will have a circle through origin. Okay. Circle through origin here. Okay. And now a is not equal to 0 but d is equal to 0. When d is equal to 0 in the w plane, I will have a line not passing through origin. I will have a straight line, okay, not passing through origin, because a is not equal to 0, not passing through origin. Okay. Now the last case, a equal to 0 and d is not equal to 0. When I take a equal to 0 in the z plane, this part, namely a coefficient of x squared plus y squared is 0. So you will not have x squared plus y squared. You will have a straight line through origin, straight line not passing through origin, not passing through origin. Because here d is not equal to 0. Okay. So now when I find its image, d is not equal to 0 but a is equal to 0, I will have a circle through origin. I will have a circle through origin. So in this case, circle gets mapped to circle, straight line gets mapped to straight line, with restrictions on A and D, and a circle in some cases gets mapped to the straight line, and the straight line in Z plane gets mapped to circles, or in general circles or straight lines in Z plane gets mapped to circles or straight lines, okay, in the W plane mapped to this. So in this case, this is how you discuss a particular transformation. You require two planes to discuss a transformation in the using the complex valued functions. So for our convenience, I have taken the curve a into x squared plus y squared plus 2bx plus 2cy plus d is equal to 0. I have found out the corresponding image, and depending upon the values of the constant, I am particularizing the image here. So if at all, if you want to discuss a transformation, you take a convenient functions in the Z plane and find the corresponding images in the W plane. So this completes the discussion about the transformation W is equal to 1 by Z. In the future lectures, we will discuss about another transformation, namely W is equal to sin Z.